So here we have another problem, and I want you to do this one. So notice here's the stresses on the vertical plane. These are the stresses on the horizontal plane. Begin by filling out this table, and then draw the, we want to know all these things: the center, the radius, beta, sigma 1, sigma 3, tau max, and draw the circle. So pause the video, do this problem. All right, I assume that you've done it, so let's take a look at this. And I'll do this sort of in two steps, but the first thing we do is, we can fill in this table. So on the vertical plane, that's the vertical plane, I see what? I see 4, I see 3. So I write sigma and tau 4, 3. Horizontal plane, I see that's a -8, and that is a -3. This is -8 because it's compression. It's showing compression. That's -8. This is -3 because it is a counterclockwise rotation about the center. So -8, -3 for the horizontal plane. So the first thing I do then is I plot these points, and label them 4, 3, vertical plane, 8, -3, horizontal plane. So I draw that, just put on the points. And then, before I even draw the circle, I just draw a line between the 2 points, and I get this -2, 0. How do I get it? Because I take the average of those two. So it's going to be -8 plus 4 over 2 equals -2. So that gives me the center. So before you even draw the circle, the point I'm making here is that just start with all this stuff, and then I've created this triangle here. I could do this triangle over here. It's the same thing. It doesn't really matter which triangle you choose. But I've chosen this one. So what do I know? Well, I know that that distance there is, the y-coordinate is 3. This distance is going to be, you can figure this out easily, that's 6. So my radius is going to be the square root of 6 squared plus 3 squared. And that means that my sigma 1, well, let me just, sigma 1, which is the center, plus the radius, so that's going to be -2 plus, the radius, and that's sigma 1. Sigma 3 is the center minus the radius, so it's going to be -2 minus what we calculated as the radius, and then we can get beta. Beta is easy enough because we know the legs of the two triangles. So we already determined that the two triangles have legs of, that's 3 and 6, so beta is going to be equal to the arctangent of 3 over 6. Tau max is equal to the radius. So we've been able to do all of the calculations before we sketch in the circle. So at this stage, in a way, we don't even need the circle. We don't need to show the circle, but I want you to show the circle because we're going to be using it. But so here's the rest of the problem, and I've drawn the circle. So like we said, the radius square root of 6 squared plus 3 squared. Beta is the arctangent of 3 over 6. -2 plus 6.7 for sigma 1, -2 minus 6.7 for sigma 3, and there's my tau max, there's my sigma 1, there's my sigma 3. So, all right, hopefully you did well on that one. Now, I'm not showing anything, just go ahead and do this one. So make your little table. It's usually a first start. Eventually you won't have to make the table because you'll get so good at this that you'll just automatically know it. But I recommend you make the little table there, find the usual information, and draw the circle. So pause the video and solve this problem. Okay, so assuming you've solved it, what do I know? I make my little table. Well, how do I do that? I look at the vertical plane. Well, here's the vertical plane. That's compression. I mean, doesn't... So compression is negative, so it's going to be -8. This is clockwise about the center, clockwise about the center. So that makes it negative, so it's going to be -8, -2. That's tension, so that's going to be positive, +5, and that is counterclockwise about the center. So that gives us +2, so we have 5, 2. And that's on the horizontal plane. So I plot these points. I plot -8, -2, vertical plane. I plot 5, 2, horizontal plane. I put that on. Then I draw the line between the two of them. And I take the x-coordinates here. So the average of those two, 5 minus 8 over 2, -1.5. That is my center. Once I know that, I can draw my little triangle here. Again, I could draw this triangle over here if I wanted. And from that triangle, I can just use, subtraction. That's 6.5, and that's 2. So R is going to be the square root of 6.5 squared plus 2 squared. Beta is the arctangent of 2 over 6.5. Sigma 1 is the center plus the radius. Sigma 3 is the center minus the radius. And tau max is equal to the radius. So we have all of our information here. All right, and I'll ask you to do this one. So do this one. And pause the video and do this way. All right, I'll assume that you've done that. Again, now, we've done enough of these. You don't necessarily have to make the table. So I'll skip the table. There's the vertical plane, and that's -20, -8. So I just put it on there, -20, -8. Vertical plane. I'll look at this one this time, the horizontal plane. So that's what? That's -6. That's +8. So -6, 8 for the horizontal plane. It's there. I draw a line between them. I take the average of the x-coordinates. That x-coordinate is -6. That x-coordinate is -7. Or sorry, -20. So -20 minus 6 over 2. The center is at -13. If that's -13, this distance here becomes 7. This is the y-coordinate here, which is 8. So I can get the radius as being the square root of 7 squared plus 8 squared. I get the beta as the arctangent of 8 over 7. And so we have the center, we have the radius. Sigma 1 is the center plus the radius. Sigma 3 is the center minus the radius. Tau max is the radius. It's that simple. Everybody gets drawing the circles, but I show you a number of these so that you can get comfortable with it. Now try this one. So pause the video and do this one. Same things that you want to find. Okay, I'm assuming that you've done that. So what do I have? I look at I'll look at this vertical plane this time. It doesn't matter which vertical plane. I can choose either one. Okay, so what do I see? I see that is compression, so it's going to be -10. That is clockwise about the center. So that's negative 6. So that's on the vertical plane, so I write negative 10, negative 6 on the vertical plane for that one. Now I'm going to look at the horizontal plane. It doesn't matter whether I look at that one or that one. Let's look at this one. That is compression, so it's negative 20. This is clockwise around counterclockwise around the center. So that's positive. So we have negative 20, positive 6. And that's the horizontal plane. So let's just make sure that there's no confusion. This is the horizontal plane. This is the vertical plane. I draw a line between the two of them. Oops. And okay. So yeah, I get that point, I get that point, I draw a line between the two of them. I take an average of the x-coordinates. So I have negative 10 minus 20 over 2, which is negative 15. And I know, well, I could draw this triangle if I wanted to. I chose that one. It doesn't really make any difference. But showing this one, since this is negative 15, that's 5. And that is 6. That's the downward part of that. So I take the radius is the square root of 5 squared plus 6 squared. Beta is the arctangent of 6 over 5. Sigma 1 is the center plus the radius. Sigma 3 is the center minus the radius. Same thing over again, and tau max is the radius. So I have all the information I need. Now try this one. I know I'm going through way too many of these, but you should be able to get them down pat. So pause the video, do this problem. Okay, assuming you've paused it, what do I have? I look at the vertical plane, for instance. Well, what is that? That's tension, so that's 8. That's clockwise about the center, so that's negative 4. So on the vertical plane, I have 8, negative 4. 8, negative 4 on the vertical plane. Horizontal plane, that's compression, so that's negative 9. That's counterclockwise, so that's positive 4. So negative 9, 4 on the horizontal plane. Draw a line between them. I take the average of the x-coordinates, so that's going to be 8 minus 9 over 2 is negative 0.5. So that's my center. Once I know that center, then I get I'm drawing this triangle in this case. I could use this triangle, doesn't matter. And on this triangle, that makes that 8.5. That makes that, or rather this number here, 4. So the radius is the sum of 8.5, the square root of the sum of 8.5 squared plus 4 squared. Sigma 1 is the center plus the radius. Sigma 3 is the center minus the radius. Tau max is the radius. Beta is the arctangent of 4 over 8.5. Done with that one. All right, so now you have 3 of them. Hopefully you're getting good at this. Do these 3, and I'm just going to give you the answers here. So pause the video, do these 3. Okay, assuming you've done these 3, then I'm just going to I'm just going to show the points here. So what do I have? I've got on the vertical plane, this is tension, so it's positive 5. This is clockwise, so it's negative 3. Right there, vertical plane. Horizontal plane, well, that's tension, so it's positive 21. This is counterclockwise, so it's positive 3. So 21, 3 on the horizontal plane. I plot these values. 21, 3 horizontal, 5, negative 3 vertical plane. Draw a line between them, split the x-coordinates, and that gives me, split the x-coordinates, take the average of the x-coordinates, 21 plus 5 over 2. And if you do your table, you just take those two. 21 plus 5 over 2 is 13. That's my center, and that gives me, this is 8, that's 3. R is the square root of 8 squared plus 3 squared. Beta is the arctangent of 3 over 8. Sigma 1 is the center plus the radius. Sigma 3 is the center minus the radius. Okay, I am going to let you, the other problems are basically the same thing. So I want you to pause the video, take a look, hopefully you got them correct. If not, check your work, and you will hopefully get the right answer. All right, now, we've been able to make the circle, but to this point we really haven't done much with it. So the next part of this topic is figuring out how to use the Mohr circle, and the information that it gives to us is very informative. So this goes back, I'm going to just basically give you the rules for finding the stresses on a plane of interest. So in other words, when we started this discussion about Mohr circle, we decided, well, we knew what's going on in the vertical plane. We know what's going on the horizontal plane. But what happens at a plane of 45 degrees? What happens at a plane of 30 degrees? What happens at a plane like that? So, or in other words, what happens, what I mean by what happens, what are the stresses on these other planes? I know the stresses on the vertical and horizontal planes because they're drawn there. How do I get the stresses on planes other than the vertical or horizontal? And I'm not going to go through it. If you look at the derivation, you will figure out these rules in a sense. I mean, some of it's is obvious, but okay, so what we're going to say is the plane is given by an angle theta, and for instance, theta can be 15, 35, 25, 8.5. It can be many different things. So theta is going to be given, and we're going to have some rules, and you'll see why as we go along. The Mohr angle is 2 times the real angle. What do I mean by that? In other words, if my angle is 45 degrees, for instance, if my angle to the plane of interest is 45 degrees, I'm calling this the real world. This is the real world. This is the Mohr world. So we're going to have 2 different worlds here, the real world and the Mohr world. And what we find is that the Mohr angle, the angle in the Mohr world, is twice the angle in the real world. So in other words, if this is 45 degrees in the real world, in the Mohr world, we're going to see that is represented by 90 degrees. Now, let's think about it for a second as to why this might be. And it comes down to, you can see it here, we're going to be measuring, angles from the center of the Mohr circle. And here, clearly, that's the horizontal plane. This is the vertical plane. Now, in the real world, the horizontal plane and the vertical plane are separated by 90 degrees. So that's 90 degrees in the real world. But if I look at real world, but if I look at the Mohr world, what do I see? Oh, that angle is 180 degrees in the Mohr world. And that's just this. So this is just one validation of the fact that what do I see? In the Mohr world is 180, the real world is 90. Oh, it's twice as much. So the Mohr world angle is twice as big as the real world angle. And we're going to be using that. That's one of our rules. So rule 1, the Mohr angle is 2 times the real angle. And then with our sign conventions and that sort of thing, we're going to find that the direction of rotation in the Mohr world is opposite to the direction of rotation in the real world. Now that comes about because of our sign conventions, and I'll show you what I mean by that when I talk about direction of rotation. Direction of rotation, when we're looking at the Mohr diagram. So we're going to create this table that is going to help us get around the Mohr circle. And now, if you look in the literature, if you look at different textbooks, you'll see at least 5 or 6 different ways to do this. I've just found this way to be the easiest, that students make the fewest mistakes. But there are other ways out there. If you want to use a different way, that's fine. But I guarantee it's going to be confusing no matter what. And I just find that this is the easiest. If you can fill out this table, which is extremely simple, you will be able to go around the Mohr circle very easily. And so what we're going to do is we're going to have things in the real world, and then we're going to have the Mohr world. So we're going to have a starting plane, an angle, and a direction in both worlds, and we want to move from one world to the other. So sometimes we're going to go from the real world into the Mohr world. Sometimes we're going to go from the Mohr world into the real world. So that is what is coming up, and we're going to use this table. I'll show you how to use it. Now, I want to make one comment here, and that is that sometimes a problem is given like this. No, how does that, what, now? We've got, you might think that we have a little bit of an issue because I'm not being shown, I'm not being shown a horizontal plane and a vertical plane. Normally, my square looks like that. Well, how am I going to handle planes that are not vertical or horizontal in my given information? It ends up to be quite simple. And the way to do it is to just label the planes differently. So I'm going to call that plane A and plane B. And I want to be able to draw this circle. So the first thing we're going to do now here in this case, for this is an example, find the stresses on a horizontal plane. In other words, I'm not given the stresses on a horizontal plane. I'm given the stresses on some plane A and some plane B that are defined by this angle 30 degrees and that angle 60 degrees. But I do not have the stresses on the horizontal plane. In addition, I don't have the stresses on a vertical plane. So I want to find the stresses on both the vertical and horizontal plane. And to do that, we are going to draw the Mohr circle first. So in this particular case, I make my original table, but instead of horizontal and vertical, I have A and B. No difference. I look at these and, again, I see tension there. I see clockwise there. So that gives me 5, -3. And so I write on plane A, I've got positive 5, negative 3 for my sigma and tau. On plane B, again, I see tension there. I see counterclockwise there. So I'm going to get 8, 3 for plane B. Positive 8, positive 3 for plane B. I can, what can I do? I can draw that, put those points on my Mohr plot. So I simply put them out here. And so I have those plots, or those points, which are 5, negative 3, 8, 3. And then I label it. This is plane B. This is plane A. I draw a line between them. I get the center. I do, from that point forward, I do exactly what I have been doing. The center is, 8 plus 5 divided by 2. So that gives me 6.5. That gives me my center. And my radius is going to be well, I guess I haven't drawn it here. Maybe I should just sketch it over here. So, so I have 5, negative 3. So this is going to be 5, negative 3, and that is plane A. And then I have 8, positive 3, and that is plane B. Draw a line between them. Gives me my radius is, or not radius, center is 6.5. Then I can get my, from there I'm just going to ask you to do the rest. This is 3. This is going to be 1.5. So r is the square root of 3 plus 1.5. 3 square root of 3 squared plus 1.5 squared. And then beta is the arctangent of 3 over 1.5, etc., etc. Sigma 1 is the center plus the radius. Sigma 3 is the center minus the radius. Tau max is equal to the radius. We've got everything we need. So I have all that information. And in the next video, I will show you how to find the stresses on the horizontal plane. Okay, so I'm going to stop there. We have the circle.